Alright guys, last section of this chapter, section 8, we'll be talking about probability of compound events. So previously we talked about simple events where we were just looking for one outcome. Compound events, vocabulary here, consist of two or more simple events. In order to find our possibilities for your compound events, you can make a table, you can make a tree diagram, you can make an organized list of all the outcomes and then count them up. So if we look at our first example, a pet store sells aquariums in 3 shapes, a hexagon, a pentagon, and a rectangle, in 2 sizes, either 10 gallons or 20 gallons. I want to use this information to find how many different fish tanks can be made from the different shapes and sizes. Okay, so compound event here because we have the shapes to think about and we have the size to think about. So for this example, I'm going to make a tree diagram. So we have our hexagon option, we have our pentagon option, and we have our rectangular option. So if you choose the hexagon, you could either choose the 10 gallon or the 20 gallon. Same thing for your pentagon, you could have 10 gallon or 20 gallon. And lastly, rectangle, you could choose a 10 gallon or a 20 gallon. So total, we see we have 1, 2, 3, 4, 5, 6 options. So there are 6 different tanks that you could choose from. Okay, so that one wasn't too bad. We had 3 options to start with, and then off of that option, we only had 2 to choose from. If we look at our next example, students are assigned a temporary password the first time they visit the computer lab. Temporary passwords consist of a letter A, B, or C, followed by a number 1 or 2, then followed by a letter X, Y, or Z. I want to know how many different temporary passwords are there. So if I started making a list, so make an organized list here, starting with the letter A. So we could do A, then 1, then X. We could do A, 1, then Y, A, 1, then Z. Okay, so now if I chose, sticking with A still, but followed by a 2, we could do A2X, A2Y, or A2Z. So there's my options if I would choose A as my first letter. Then we have to go through and do the same thing with B. So we have B1X, B1Y, B1Z. Then switching over to the 2, B2X, B2Y, and B2Z. And last, do the same thing with our C. Hopefully we're seeing a pattern here. So C1X, C1Y, C1Z, then we have C2X, C2Z, we're not order there, C2Y rather, and last C2Z. Let's count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16, 17, 18 different temporary passwords. So still not too bad, but you see our list is getting longer. So if we take a look at our next option, a pizza shop has regular, deep dish, and thin crust pizzas, 2 different types of cheeses, and 5 toppings. How many different 1 cheese, 1 topping pizzas can be ordered? So if we take out the information here, we have 3 crusts to choose from. We have 2 cheese to choose from, and 5 toppings to choose from. So right away I see that this one's going to be even longer. So before we figure this out by making a list or making a table or making a tree diagram, make sure you remember that those are options. If you flip to the next page, we see our fundamental counting principle. If event M can occur in M ways and is followed by event N that can occur in N ways, then the event M followed by N can occur in M times N ways. Okay, so a lot of words there, kind of jumbled, but if you look at the example, if there are 4 possible sizes for fish tanks, and 3 possible shapes, then there are 4 times 3 or 12 possible fish tanks. So if we flip back to our pizza, so I have 3 ways the first event can happen times 2 ways the second event can happen, that's our cheese, times 5 toppings, so 5 ways that third event can happen. We just take 3 times 2 times 5, which gives us 30 different pizzas. So as you can see, instead of making that chart, which would have taken even longer on this example since there are 5 choices at the end there, we can just take the different number from each category and multiply them together, cutting out a lot of work. But again, remember, those other options are always available to you. So if we flip back, Lamar is going to spin each spinner once. What is the probability that he will spin red and the number 9? First off, I want to think about this first spinner. There are 5 different color options, 10 different numbers. So I know that there are 50 possible outcomes from spinning those 2 spinners. Now I want to know the probability though that I spin red and 9. So probability, we need to think about fractions. Remember, probability is a number between 0 and 1 or a percentage. So we're not looking at that 50 as our answer. So the probability that we spin red, well, there is only one way that I can get red because there's only 1 red piece here. But there were 5 total possibilities. So then times the number 9, and there's only 1 9 here, so only one way to get the 9, but there are 10 possible numbers. So we multiply these fractions together just like we would have multiplied over here to get that our probability is 1 over 50, which is 2%. So our answer here, he has a 2% chance that he will spin a red and a 9 on those 2 spinners. All right, that's the end of this lesson, the end of the chapter.